more has more power. The second topic for the academic.
Okay. Hello everyone. For the people who was not here in the morning, or the first one, my name is Ahmed Rabia. I'm from Egypt. Professor Terribile is my co-author in this research, and he is also my supervisor in my PhD study here in Italy. This study also about land suitability analysis, but the first one was application of the analysis. This one is more study about the methodology of the analysis. So in this case, we are introducing a new equation of land suitability analysis, which can be used in other application for suitability analysis. This study was under a project of between our university enabled and the European Union, which is a live project with this title. You can also visit the website of the project here, Land Consulting Web EU. So again, land suitability is choosing or testing the suitability of a certain part of land for certain land use. So this will involve in many factors which are affecting the suitability of this land use in this certain part of land. In general, suitability analysis will answer two questions, which is which and where. Which land use to apply, which kind of land use to apply, and where exactly to apply this land use, where in your study area. So different applications of suitability analysis, you can apply for different applications. Of course, in my background is more close to agriculture, but also you can use it in your study field. So there is two major methods of suitability analysis. The first one is limitation approach. The other one is parametric approach. The limitation approach is is two methods: the simple limitation and the limitation regarding the number and intensity. The parametric approach, there is two methods. One of them is story, the one we used in the first presentation, and the other one is root square. We are more interested here in this study about the parametric approach, which we are going to introduce a third equation or a third method of parametric analysis. So that's why we can say that the objective of this study was introducing a new parametric index, comparing this the result of this method with the classical methods, story and root square, and of course to apply this method, or to test this method, we applied land suitability analysis, that in this case was for wheat production, crop production. So in this case, our study area in this case was okay. Should be a preview. Anyway. So in our case, in this case, it's in Italy. Here in Italy, in Campania region, in a place called Valle di Lesina. The study area, total area was more than 20,000 hectares. This part is more or less in the southern part of Italy, south from here. So any suitability analysis is about factors affecting this suitability. So we can say that it's a function of different factors. These factors depend on which kind of land use you are testing. So you can make a function of these factors, and then you can have a final suitability for this land use. The approach, the parametric approach, is a 6 sequential steps, starting from collecting all the data you need, making these factors in different weights, in ratings, and then these factors, you give each factor an individual rate, and then for each factor you give a different weight because not all the factors is affecting the same weight. And then finally you calculate, the fifth step, you calculate the total score for the suitability, and finally you assign the suitability class as we said. So to show the capacity of the system, in this case, this is the modeling of this analysis, the suitability analysis, starting from all the data we need to use, and then the second step is using this data to make the factorial numbering for each factor, and then assigning the weights, and finally we reach to the final class of the suitability. So in our case, we are testing the wheat production. So in this case, there is different factors, which is, for example, calcium carbonate, organic compounds, pH, the texture, depth of the soil, drainage system in the soil, the electrical conductivity, the slope of this soil, the altitude, which is the elevation of this part of the soil. So of course, each factor has a different weight, has a different impact of this land use. And we will use these weights to assign the difference between different factors. And as we said before also, there is 5 classes, starting from the highly suitable class, and finally we get to the unsuitable or permanently unsuitable class. So in this case, the first two, the story index and the square root index, which is the classical one, and the third one is the one we are proposing to use. What is the difference between the three? The first one is using just a multiplication of all the factors. So in this case, you are not taking care about the value or the weight of each factor. In the other case, also is the same, but only here is taking care of the most limiting factor in this case. So, for example, if we, in our case, for example, in the wheat, if the lowest rating was for pH, so we use the pH rate as our minimum, and then we put all the factors, all the other factors. But in this case, maybe the pH is not very important in this case. So if you put the pH here, you are getting a lower value. You are getting a lower value here because you are using the minimum, the minimum rating.